Welcome to tonight's Larry and Betty Vadnais Environmental Issues Lecture. My name is Dan Shustak. I'm one of the faculty members in the Environmental Studies Department here at the Massachusetts College of Liberal Arts. Each year we host a lecture to commemorate the work of Professor Larry Vadnais in what Larry called Resourceful Living. This lecture series also commemorates his wife Betty, who has been described as the unsung hero of this program. This program existed here in the late 1970s and early 1980s, at which time this institution was called the North Adams State College. The Center for Resourceful Living program began nearly 50 years ago. The first environmental issues lecture that we hosted in Larry and Betty's honor was 20 years ago in 2004. We are fortunate to have a special guest to welcome you all here to MCLA and to this lecture tonight. Allow me to introduce President Dr. Jamie Burge. Dr. Burge became president of MCLA in 2016. During his time here, Dr. Burge has worked to strengthen the college's presence and impact in our local community and the Commonwealth. Dr. Burge consistently prioritizes access to higher education and the quality of the educational opportunities that we offer here at MCLA, the Commonwealth's liberal arts institution in the state's university system. Not only is Dr. Burge supportive of the Environmental Studies Department, but of sustainability more broadly at MCLA. And on a personal level, Dr. Burge enjoys walks around North Adams and fly fishing in our beautiful streams here in New England. Thank you for being here tonight, Dr. Burge.
Thank you, Dan. You could have left the part out about fly fishing in these great streams. We like to keep that a secret, by the way. Well, welcome and thank you for joining us this evening for the annual Elizabeth and Lawrence Vadnais Environmental Issues Lecture. Before I get to my remarks, I want to say thanks not only for your presence tonight, but for sharing those oral histories. I was sitting in the back as you were speaking, and hearing those stories are really important, not just for you to recall some of those great experiences that you had as students here, but they're important for me and my colleagues here to hear those stories too, because they're very much a part of the history of this place. And in fact, your stories resonate in this building because it is, in fact, a legacy of the kinds of things that you did so many years ago. And so I'm grateful for you taking the time to share those stories, to reflect on the great experiences that you had. I've loved watching some of you reconnect and hug and see each other. That's what an academic community does. We love that. That's the best part about being in a place like MCLA, where we get to talk about the important things in life, not just academic, but the kinds of things that we interact with one another and with the academic world as well. But that creates an energy, that creates a life that's meaningful and that persists beyond just having been here for 4 years to study a particular discipline, but to go beyond and to live a life that's fulfilling and a life that's elevated in a way that it wouldn't be without the experiences that you've had with other people here. So thanks so much for sharing those stories. Those oral histories are powerful, they're important, and I'm so grateful for you sharing them in this space this evening. Larry Vadnais came to MCLA, known then, of course, as North Adams State College, to earn a Master's of Arts degree. In 1968, having become a seasoned educator, Larry returned to North Adams State as a professor. In the 70s and 80s, Larry and Betty worked with the MCLA students to establish a radical hands-on exploration of environmental sustainability called the Center for Resourceful Living, which included a teaching farm where students and the Vadnais family experimented with methods of sustainable agriculture and renewable energy, among other topics. The Center for Resourceful Living profoundly changed the lives of you and many other students. While the Center for Resourceful Living no longer exists at MCLA, our Environmental Studies Department continues to provide a hands-on education in environmental science and sustainability, where a community of students and faculty work closely together to understand and address those same issues that threaten the future of the planet as we know it. For example, on a recent night, Professor Shustak, students and community members participated in an effort to ban owls in the Hopkins Forest, providing data for important research on those owls. I think it's important to note that throughout the United States, including MCLA's campus and the surrounding area, people reside on land forcibly taken by Native Americans or from Native Americans. With gratitude and humility, we respectfully acknowledge that Massachusetts College of Liberal Arts stands on the ancestral homelands of the Stockbridge-Munsee Mohicans, who are the indigenous peoples of this land. Following tremendous hardship after being forced from their valued homelands, they continued as a sovereign tribal nation in Wisconsin, which is where they reside today. We pay honor and respect to their ancestors, past and present, as we commit to building a more inclusive, sustainable, and equitable space for all. Last May, I had the distinct pleasure of conferring an honorary doctorate on Shannon Holsey, the president of the Stockbridge-Munsee Band of Mohicans. This evening's speaker is Dr. Ariana Chiapella, a 2012 alumna of MCLA, who conducts research at the Rubenstein Ecosystem Laboratory, where she explores basic to applied questions about the impacts of stressors on the aquatic ecosystem and implications for people and management. Today, we continue our tradition of educating students to be informed, active, and resourceful citizens at MCLA, including in our environmental studies program. I'd like now to introduce Professor Ariana Chiapella, who will in turn introduce Dr. Chiapella. Professor Chiapella has been teaching in the environmental studies program at MCLA for over a decade and currently serves as chair of the department as well as coordinator of the campus sustainability initiative. With a background in aquatic ecology, Dr. Chiapella works closely with students and collaborates with environmental agencies and organizations on long-term projects to aid in river restoration planning and to identify and eliminate sources of pollution to local rivers. Elena developed MCLA's Green Living Seminar into an annual public lecture series focusing on sustainability and engaging students in working to address regional environmental challenges in partnership with collaborating institutions. Please welcome Dr. Chiapella.
Thank you, President Byrd, for that introduction and for being here tonight and for your support of environmental studies here at MCLA. Before I introduce our speaker for today, where did Dan go? Dan, where are you? There you are. So I'd like to say a really, really big thank you to Dan, who, Dr. Dan Schustak, spent an incredible amount of time and care putting this event together to celebrate the 50th anniversary of the Center for Resourceful Living. So can we all just thank Dan very much? Thanks. So it's really always an honor when I have the opportunity to introduce the Vadnais Environmental Lecture speaker. But tonight is special because tonight's speaker, Dr. Ariana Chiapella, was our student. She took some of the same courses as some students who are sitting here today. We're glad to see you, by the way. And like many of our students, she got involved with research, internships, and other hands-on learning experiences early and often. It was my great fortune that Ari volunteered to work on a project with me in which we tracked down sources of bacterial pollution to the Hoosic River. During her first semester at MCLA, she collaborated with a team of students to submit a grant proposal to fund this project. After the grant proposal was approved, Ari designed the sampling protocols, selected the sample sites by riding her bicycle around town, and trained the students who would carry out the research the following summer. One of whom is here. Thanks for coming. This work ultimately resulted in the identification and remediation of several sources of bacterial contamination, which further led to the improvement of water quality in the Hoosic River. Thank you. At the same time, as this work was going on, Ari explored the region and beyond in her involvement with the Outing Club and a week-long camping exploration of the Everglades with Dan's travel course to South Florida. She also tutored other students and presented guest lectures in my Introduction to Environmental Systems class, for which she served as a teaching assistant. She carried out summer research on PCBs in the Hoosic River with faculty, thanks so much for coming, from Williams College and other Williams College students. And as part of a Green Living Seminar community-based learning project, she was part of a team of students who created a short documentary about TCE contamination in North Adams groundwater, which you can still find up on YouTube if you want to learn more about that issue. Now Ari is a lecturer at the Rubenstein School of Environmental and Natural Resources at the University of Vermont. Her work investigates new frontiers in aquatic ecology and environmental health, and true to her academic roots in the liberal arts and to the ideals of the Center for Resourceful Living, her research is interdisciplinary and her teaching is based in active learning, deliberative democracy, and involves engaging her students in research and community-based projects. Her research focuses on topics ranging from how invasive quagga mussels may impact fish in Lake Champlain, to how mercury moves through mountain lake ecosystems, to why toxic chemical governance in the US still fails to protect people from exposure to toxic chemicals, among other pursuits. And so, it's with immense admiration and appreciation that I introduce to you Dr. Ariana Chiapella.
You pretty much stole my intro, Elena, so thanks for that. Hi, everyone. Thanks so much for coming. It's truly an honor to be here and really fun to come back to North Adams for this. So, as Elena's introduction insinuated, and as I'll talk about now, my research career has really centered around this intersection between human communities and aquatic communities and how contaminants interact with both and bridge the two. It all started at the University of New Hampshire, where I quickly racked up a bunch of debt, realized I didn't want to be at a big university, and bailed. So then I went to 2 community colleges. First I went north to Maine and then south to Florida for some reason. I don't know why, but finally I ended up at MCLA. And it was honestly a bit of a financial decision. I was like, okay, what's the school that has the cheapest in-state tuition, because I'm from Massachusetts, and also has a major that's of interest to me. So I found MCLA, just like, just gonna try and get out of this with as little debt as possible. But once I got here, I realized this was my place. So it was really, I mean, I didn't do much research aside from like, you know, those parameters that I just mentioned. But at MCLA, I really found my people. So I joined the outdoors club. I actually ended up as the president of the yoga club. This was the early days of YouTube, so we played around a little bit with making an advertisement for the yoga club. That's me in the center there. And on my first, I think it might have been my first day, that's how I remember it, of taking Dr. Elena Traster's Intro to Environmental Systems class. I was like, oh, what she does is really cool. And I walked up to her and was just like, can I help you with your research? Which at UVM would get you exactly nowhere. You need to write like a well-crafted email explaining how your skills fit with the skills of the professor you want to work with. But at MCLA, it's a smaller school and fewer barriers, and students have a lot more opportunity to get involved. So I was able to really easily. So it led to me becoming part of my first research project, presenting my first research poster. So ahead of this talk, I did a lot of you're not meant to be able to read this, but just to see that it exists. So I did a lot of research ahead of this talk, trying to find remnants of my time here. And so I found this in a very old Google Drive folder. And as Elena mentioned, I also had a project where I joined together with another student to investigate the history of TCE contamination in North Adams. So just out of curiosity, show of hands, how many of you are familiar with this issue? Okay, a handful of you. Because of the video. Okay, so here's the thing. I was like, I should probably refresh my memory on this issue before I come to this talk. So again, did a Google search, and my video was pretty much the only thing that came up. And I have to admit, it's a little bit embarrassing, but I'm also pretty proud that this is one of the few pieces of information that exists on this topic. And I was scrolling through the comments, and some of them are as recent as a year ago. And so this is kind of bringing to light a major theme that I've kind of tried to hold on to throughout my career, where I'm really interested both in the intersection, of, like I said, of people and aquatic systems and the impact of contaminants, but also this kind of environmental justice aspect of it too, where the people who are most marginalized, so our low-income communities, our people of color communities, indigenous communities are the most impacted by environmental contamination. And so all of this really set the stage. Oh, and of course, my final summer, I spent some time at Williams College looking at PCBs in the Hoosick River food web. Oops. But crayfish were the biggest victim of our studies. Okay, so what I thought I would do is kind of map out my path here in terms of different research projects I've worked on between my time at MCLA and now. And so like I said, my research really, I'm either kind of looking into the impact of contaminants on human communities or in aquatic communities. Sometimes I stray a little more to the peripherals of this diagram. But part of the reason contaminants create an intersection is because human communities create the problem of contamination to begin with, right? We've had rapid technological advances that have outpaced our government's ability to keep up with their disposal and spread with adequate regulation, which means that as we produce contaminants and release them into the environment, they get transported around the globe, and one of the major reservoirs that collects contaminants is our aquatic ecosystems, which has an impact on our aquatic life. Thank you. So once we get contaminants in an aquatic ecosystem, it depends on the compound, but generally what tends to happen is that these compounds get in the food web and they accumulate at higher and higher amounts as you move up the food web. Ultimately meaning that organisms like fish end up with the highest amounts, even if there's only a little bit in the water or the sediment to begin with. Which then feeds back to our human communities, right? Because a lot of people rely on fish as a source of food. And so kind of the other side of my research is not just how contaminants accumulate and move through food webs and why, but then what is the impact for people? So I've looked at this issue both from alpine lakes all the way down to the Winooski River watershed, which is a river that feeds into Lake Champlain in Burlington, Vermont. Yes, so contaminants really sit in the middle there. And so I won't go in depth into all the different types of contaminants. These are a few kind of groups that I brainstormed, but the ones that I'm really focused on are heavy metals, and then these other industrial compounds. So I grouped them as chlorinated, fluorinated, and brominated compounds. So PCBs are in that category, and then PFAS as well. So forever chemicals, which I'm guessing most people who live in this area are familiar with those. All right, you can go to the next one. Okay, so broadly, where did these two types of contaminants come from? So I'm gonna focus today on mercury and PFAS. So those are the two most prominent in my research. So mercury largely has come from coal mining and combustion. Sometimes there's kind of acute exposures to aquatic communities from mine leachate, but overall it's the transport and combustion of coal that has led to widespread mercury contamination globally. Side note, have any of you ever ridden the Mount Washington Cog Railway? So I did that for the first time just a few weeks ago, and one of their trains that they send up is still coal powered. And so it's the first time I've actually seen in person a huge plume of coal smoke and just how terrible it looks. And then took the train to the top and then walked back down the mountain, and there was just coal spread out along the railroad tracks the whole way down. And so back when we relied on coal kind of in a more widespread way, we had kind of direct contamination to the environment, both with its combustion, we're just releasing the mercury and the coal right into the atmosphere, but also it's getting spread on the ground just because sometimes it's really hard to contain the compounds that you're using. So PFAS are in so many different things. Non-stick coatings on cookware is probably what a lot of you are most familiar with, but it's also stain, fire, and water resistant and used as coatings on clothing and countless other consumer products. It's also used in the manufacturing of industrial products, and also in firefighting foam. And so I'll show you a little bit later why that's relevant to what I'm doing. So we have lots of different routes of release or exposure to the environment for PFAS. And so, like I mentioned, this area here is probably pretty familiar with PFAS due to the, I think it was it improper dumping of chemical waste from the ChemFab plant in Bennington. It's still, this was an article from 2023, I believe. It's still showing up in people's wells. So if we were to broadly talk about why these contaminants are a problem for human health, mercury is neurotoxic. It can be associated with developmental delays, disruptions of fine motor function, immunosuppression, even decreased fertility. PFAS, they can interrupt with proper hormone function, they can be carcinogenic, and they also have some pretty significant impacts on liver function. All right, so like I said, my research has kind of spanned both aquatic and human communities, but also from our headwaters all the way down to large lakes. So up there, that's Tapto Lake again from that first slide. In the middle here is the Winooski River, which then drains into Lake Champlain. So I'm going to start talking about some research that I did during grad school that really kind of investigates contaminants from the aquatic food web side. And then I'm going to move to research that's more active right now and look at, tell you all about some research I'm doing looking at the human side, the exposure risk side, by taking a look at the potential impact of PFAS for some vulnerable communities in the Burlington area. All right. So I'm going to start with this question. What lives in an alpine lake? Feel free to audience for some audience participation. Okay, a lot of you said fish. Do you think fish always lived in alpine lakes? A lot of alpine lakes historically were fishless, in part because the watersheds leading up to the lakes are so steep. There was no ways for fish to actually get to them and colonize them. And so historically, before we started stocking our alpine lakes with fish, we had pretty small food webs. We have two kind of sides of the food web in an alpine lake or in any lake. The first is the pelagic. The pelagic food web is supported by phytoplankton, which then are eaten by zooplankton. So we have both small, tiny little zooplankton that we probably can't see very well without a microscope, and then we have larger zooplankton like cladocerans and copepods. Those of you who have seen SpongeBob SquarePants, plankton is a copepod. So these are slightly larger. You could, if you were to collect a water sample, you could actually kind of see that they exist with the naked eye. And then, so this is a pelagic food web. Yeah. And then we also have a benthic food web. So this is fed by primary producers that grow on the bottom of the lake. So if you've ever seen a slimy rock in a river or a pond, it's covered in periphyton, which is a combination of algae and microbes. And this gets eaten by aquatic macroinvertebrates, so basically insects that live in the water. There they are. So we've got little ones, bigger ones. Some of the bigger ones emerged to be terrestrial insects in their adult life phases. And then some lakes have amphibians. So this is the mountain yellow-legged frog. And so the only thing that's really connecting these two food webs is the frogs. They might eat some zooplankton. They're largely eating stuff from the bottom of the lake, so our invertebrates. So there's really not much kind of transfer of energy or nutrients between those two pathways, those two food webs in an alpine lake. But what happens when you add fish? So historically, pre-World War I and II, these lakes were stocked by people hiking them up with backpacks. Actually, even John Muir was a proponent of stocking alpine lakes because he thought if we can get people interested in coming to fish in these lakes and they'll want to conserve these beautiful areas, little did we know, it was a pretty bad idea. Once you add fish, they eat whatever's in sight. There's not a lot in those food webs to begin with. The nutrient levels are really low, so the the amount of primary producers just can't support a lot of biomass, a lot of different animals. And so when the fish come in, they're a novel source of nutrients, but then they also just mow down. They eat tadpole eggs and tadpoles, or sorry, frog eggs, tadpoles, the large macroinvertebrates, the larger zooplankton, which means there's a lot less top-down pressure on the primary producers. So you get algae blooms, you get a lot more primary production on the bottom of the lake, so it's just slimier rocks. You can think of it that way. And then we've also got a much stronger connection between the pelagic and benthic food webs in the lake. And the biggest thing is they're accumulating a lot of contaminants, so a lot of mercury relative to what's present in the food webs. Again, because they're just kind of eating everything, and so they end up being a reservoir of mercury. So people come up to these lakes thinking they're going to eat a really pristine fish, when the reality is mercury is everywhere, and so you can't escape it even if you hike to an alpine lake. So some of the kind of social and management implications of stocking fish in these alpine lakes, well, the obvious one is mercury exposure. If people are coming to fish in these lakes and they eat the fish, that's a potential source of mercury. But now that the people who manage these lakes, so largely national forests and national parks, have figured out that it's bad for the food webs to put fish in the lakes, they started to take them out. So they would do that with gill nets. So it's hard to tell, but this is a person in like a little floaty, basically, setting a gill net. And the goal of that is to catch as many fish and remove them from the lake as possible. A piscicide, so a chemical that's toxic to fish, is also used for fish removal. It can be neutralized to lake outlet. But, like I said, the lakes have been stocked since the late 1800s, and so there's a lot of people who place a lot of value on being able to fish at these lakes. And so there are a lot of people who are really angry when parks and national forests started to remove fish. And so those groups kind of banded together and would go and vandalize gill nets when they were set. They would figure out if a lake had had fish removal, and they would go to a lake that hadn't. They would fish, put the fish in buckets, and hike them over to the lake that had the fish removal and restock it. And actually, these groups started to organize so much that they lobbied Congress to pass something called, so this is in the state of Washington, the North Cascades Fish Stocking Act of 2014, which basically mandated that a certain number of lakes needed to continue to be stocked with fish, even though largely national forests and national parks had stopped stocking fish and started removing fish. So my project, I was hoping to try and understand how is mercury accumulating in the food webs, and can we come up with a few different variables that are easy to measure and look at so that we can identify which lakes are at higher risk of having higher mercury fish, so that maybe the national parks or the national forests don't have to go and test fish from every single lake, but they can kind of look at a few key characteristics and make decisions about which lakes to stock or not stock based on whether or not the fish would accumulate a lot of mercury. So I was, like I said, working in Washington State. Here's North Cascades National Park, Olympic National Park, and Mount Rainier National Park. I ended up having usable data from almost 20 lakes. These are really hard to get to. A lot of them are like 10 to 20 miles of hiking to get to them. I definitely messed up my knees for life when I was doing this research. And at each of these lakes, I sampled the food webs plus a bunch of other variables. And the whole goal was to try, like I said, try and figure out which lakes had fish with higher mercury, and figure out what was associated with that. So that's me in my inflatable kayak that I hiked into the lakes in a zooplankton net, caught some fish, filtered some water for phytoplankton and chlorophyll, etc. This is actually, I was trying to map the bottom of the lakes as well. So I paddled around the lake in circles until I covered most of the lake and got data on how deep it was at various points, and then used that to model some things. I won't go too in depth into it, but you can switch to the next one. But my thought was there's probably some key drivers of mercury at different scales, right? So we've got the landscape scale, so things that are happening at the landscape level like temperature, precipitation, and realized that something like tree cover could kind of be a variable that incorporates all of those things into one representative variable. At kind of the lake scale, I looked at benthic primary production, so basically how much periphyton was growing at the bottom of a lake. And then at the food web level, I was trying to figure out fish diet. So here's an example of one of the maps I made with my like inflatable kayak sonar data. And so that's part of the way I modeled how much periphyton was growing at the bottom of the lake. But this is kind of like my basic idea of what the food web looked like, which is pretty similar to what I showed you a few slides ago. And there's this really cool tool called stable isotope analysis, which is basically, to really oversimplify it, you can look at stable isotopes of carbon and nitrogen and figure out where in a food web an animal is eating. So how pelagic is its food, how benthic is its food, and what's its trophic position? So how high up in the food web is it eating? So I looked at that as well. So I kind of looked first broadly at mercury trends, and so here's our 3 national parks, Mount Rainier, North Cascades, and Olympic, and I didn't see any difference in mercury, which means it was being pretty consistently distributed among the 3 parks. We had 3 different species of fish that showed up in these lakes, so cutthroat trout, eastern brook trout, and rainbow trout. Rainbow trout had lower mercury than the other 2 trout, and luckily all of the fish were below the EPA threshold for what's safe to eat if you're just recreationally fishing, so eating fish occasionally. But a good number of fish were above the EPA's threshold of what's safe if you're subsistence fishing, which means relying on fish as an important source of your food. When I looked at the stable isotopes, I found that surprisingly, the fish, their kind of like average diet sat right in between that pelagic food web and the benthic food web. So they really were connecting those 2 food webs and kind of crossing the nutrients and energy that way, just right down the middle. So like I said, we've got increasing trophic position here, and then this is going to be our pelagic food web and our benthic food web. And what I found of all the different variables I was testing is that fish with higher mercury came from lakes that had a higher % tree cover, and they were also relying more on benthic food. So again, when I was doing the stable isotope analysis, I could figure out for each individual fish kind of how much of its food was coming from zooplankton or benthic invertebrates. And so I made this little diagram here. This is a lake that has more trees, and this fish is eating a benthic invertebrate. Looks kind of unhappy because its mercury levels are higher. Down here, this fish is happy because it's eating zooplankton, which are from the pelagic food web, and it's in a very alpine lake without many trees. So it's good, lower mercury. So what are the implications of this? Well, first of all, now the National Park Service and the National Forest Service can say, all right, so lakes with more forest cover are going to probably have fish that accumulate higher levels of mercury. So maybe we stock lakes that have less tree cover. Lakes that also have more benthic invertebrates, which means that's probably more what the fish are eating, are also going to tend to be shallower and have more kind of extended shoreline, shallow shoreline. And so again, maybe just looking at some satellite imagery or having a little bit of information about a lake, you can figure out which lakes are going to be higher risk or lower risk. But we also have to think about climate change. Tree lines are going to probably shift higher in altitude as our climate warms up, which means more lakes are going to become a little bit more forested. So these are things we need to keep in mind, again, with management as we move forward. In addition to the, so this is a paper I published, basically giving an overview of what I just told you. But in addition to that, I also surveyed a lot of visitors to figure out, so if they knew about contamination of fish, if they thought fish in alpine lakes were safe to eat, if they participated in fishing, if they ate the fish. And so I think if you go back one more slide, I found that maybe 13% of visitors, 13% of visitors who go to those lakes angle and eat the fish, which extrapolates out to about 150,000 people per year in the state of Washington. And so a lot of people are going to these lakes and eating fish. Another thing that I've always kept in mind is, like, why do we keep having widespread issues of environmental contamination? And so I'll just briefly touch on, me and a group of other scientists wrote this paper trying to understand basically how our regulations are still failing us, why we still keep having environmental crises with contaminants. This was around the time of the Flint, Michigan water crisis. I was living in Portland, Oregon, and a biomonitoring study with lichen figured out that there were some small local factories that were releasing really high levels of arsenic and cadmium, polluted a bunch of people's yards. And so these events led us to write this paper. And so this is, again, more on the human community side of this nexus right here. And so for a while, I really wandered more towards the aquatic community side of this, stopped looking at contaminants for a little bit, and really focused on food webs, aquatic food webs. And so, published a few papers looking at very basic research, like why is a food web structured the way it is? I went to Austria for a little bit, ran some experiments with some new diet tracing techniques. So sometimes that tool, stable isotopes that I mentioned, leaves out some detail that we need. So I tried out some new techniques. So I kind of wandered farther to the right of that diagram than I wanted to for a bit. And then when I started teaching at UVM, one of the classes I started teaching was a required class for first-year students in our department. And what this class does is teach students about how issues of environmental disasters or stressors can't be untangled from issues of racism. And so in addition to teaching this class, I'd already been thinking a lot about how my research was really kind of missing this equity piece, and how I could really use my privilege, both as someone who's white and middle class, but also someone who's a scientist, to really start asking questions that benefited more people who needed a voice. So that led me to the final thing I'm going to talk to you about tonight, which is the implications of contaminants for subsistence anglers. So people who fish as an important source of food, basically. You can go to the next one. So fish are really nutritious. They're low in saturated fat, high in protein. They provide us with essential fatty acids that are really hard to get from other kinds of food. They provide us with essential nutrients like iodine and vitamin D. And so because of that, if you go to the next slide, fish are especially important for communities that are food insecure. This is because they're a source of fresh, high-quality food. You can go back, sorry. Back a little bit more, yeah. They can be harvested for very little cost, especially once you have fishing gear. It's easy for someone to go out and fish their own food, so they can supplement any other sort of assistance they're getting and gain some food security. It's also really important for community building for a lot of people to go out and fish with other people from the community, and it can even be used as a source of income or means of trade. And this risk is potentially even higher for our immigrant, refugee, and indigenous communities. These communities tend to eat a lot more fish than the average American and have lower awareness of advisories. So for indigenous communities, this is probably because of a bit of lack of trust and engagement with government. And then for our immigrant and refugee communities, largely it's an issue of language barriers. They also might consume fish species that aren't tested by the states because the state might assume that recreationally important species is or the species we need to test. So one great example, that picture on the right was of a lamprey. So lamprey are really long-lived, accumulate a lot of contaminants, but generally aren't tested. So this issue of higher contaminant exposure in marginalized communities is widespread. I probably will skip over these a little bit for the sake of time, but everywhere from New York to the Midwest to California, we're seeing higher rates of exposure to contaminants. But what about in Vermont? So Vermont is a very white state, but we also have a really vibrant refugee community, especially around the Burlington area. And this issue of exposure risk has really been on my mind since I got to UVM, and wondering if our state's advisories are adequately protecting our immigrant and refugee communities. So we have a number of known high contaminant fish in Vermont. So this is a smattering of what those are. PFAS is a contaminant that we're just starting to test for in Vermont, but we don't have enough data yet to have an advisory for, and it's a really pressing concern. We have high PFAS in our municipal wastewater effluent, but also we have industrial sites that are treating their own wastewater, not taking out PFAS. And then we also have the Air National Guard, which is in South Burlington, and they have firefighting foam stored on site that has lots of PFAS in it. And so my original goal was to play this video for you, but it had an ad and it was too annoying. So I've got a screenshot of it. But you can see down here that there's a lot of that foam leaking into the facility. And that actually happened this past summer, back in July. And this foam went through the drains of the hangar into our municipal wastewater, and then that plant basically shut off the inflow pipes because they were like, we can't handle this, and then it overflowed into the river. So even though we don't have a lot of information on PFAS yet, this is a really big concern in terms of exposure to people who eat fish. So in Vermont, we've had some success banning them from consumer products, but this ban is limited. And like I said, we don't have an advisory yet in the state of Vermont. There's one part of the New York side where New York State has got an advisory. That said, our brave little state is working on testing enough fish and enough water samples to eventually have an advisory. And I thought this is the perfect time to try and inform those efforts so that it's done in a representative way. So this is, that in that right-hand corner was one of I think they produce microchips, and so they had their own wastewater treatment facility, and they released PFAS into the river. So now you can go to the next slide. So I started a project to try and figure out if our advisories are equitable and effective, and try and figure out how we can best inform these future efforts for PFAS testing and an eventual advisory. And so this is the first project I did that used what's called community participatory research. If you go back. And so I partnered with a number of other professors at UVM, including someone from our medical college, the Vermont Department of Environmental Conservation that does the testing, the Department of Health that does the advisories and outreach, but also with a local activist group that's doing a lot of work with PFAS. They actually were a huge player in getting PFAS legislation passed in Vermont. And then we had a number of community partners who were representing some of the communities we wanted to work with, including someone who was a member of an Abenaki tribe. And a lot of this work was actually done supported by an undergraduate honors student. So Eli right here did his honors thesis on this project. And then kind of a broader scale project was done by my grad student, Saurav, who actually came in from Nepal to work on this project. So So, this is our existing mercury advisory. Do you think it is accessible to a broad number of people? I don't even want to read that. It's obviously all in English. There's no graphics. It's not very helpful. And the state knows this. They're actually about to release an updated version. They're going to have translated materials, a lot more graphics, so you can kind of figure out what to do visually, which is great. And we've been kind of working with them on that. But this means that our exposure risk to certain communities is probably higher. So this project used a combination of quantitative surveys. So we basically had people take an online or paper survey through a number of different means. And then we did focus groups with 3 different refugee communities. And so to summarize some concerns, we also saw that there were some species, for example, lamprey, that were targeted, that the state doesn't really test for contaminants. Preparation techniques are broadly different than what consumption advisories recommend. Knowledge of advisories is very minimal, so only 2 total participants across all of the groups even heard of fish advisories. And then, as some of those past quotes identified, their understanding of contaminants in fish is really misguided. So some people said they think that the contaminants can get cooked off, or that they could detect their presence by taste or smell. And then a lot of these communities also fished at potentially higher risk sites. So the Winooski River runs through the town, or the city of Winooski, which is where a lot of these communities resettle to. And it's great because you can walk down to the river. However, a popular fishing site among these communities was a place called Salmon Hole, which is on the Winooski River, downstream of Global Foundries, downstream of the Air National Guard. And so after that spill that we had over the summer, there was a notice posted at Salmon Hole, but as you can see, in English, all text. If you didn't speak English, you might walk right by that and have no idea it's warning you about something. So again, the state really needs to improve its outreach efforts. So now what? Like I said, we're working with the Vermont agencies that are doing testing and creating the advisories, and so we're using our data to inform those efforts. We're regularly in touch with them. The Department of Health has identified inclusiveness as a major issue, so they're already updating the mercury advisory, and it still only applies, again, to mercury and in some cases PCBs. But our hope is that once they do make the PFAS advisory, they'll incorporate these same principles. And we hope that pending more funding, we'll be able to improve their outreach as well. So in our focus groups, community members expressed that WhatsApp groups with a community partner or translator could be really helpful for kind of answering questions and disseminating information. The Department of Fish and Wildlife and Lake Champlain Sea Grant already run fishing clinics for new Americans, and so working with them to integrate contaminant education is going to be a really important next step. And then we've also discussed eventually partnering with schools to do outreach. A lot of these families who come to Vermont have children in the schools, and so if we can teach the children about contamination in fish, they might also be able to help inform their parents as well. So now more than ever, we need to be doing this kind of interdisciplinary work, right, to try and protect our most vulnerable communities. And I think, we've made a lot of progress in this, but there's still a lot to do, especially now. And so I'm hoping to keep doing this kind of work. And again, I feel like everything I've done, especially now, can really be traced back to my time here at MCLA. And so for that, I'll be forever grateful. And if you're curious about that documentary that Ellie and I both mentioned, I do have it at the end. And so maybe before we play it, I'll answer any questions if you have any. Thanks so much.